Yeah, hi everyone. So today we are going to study a new topic, which is rerun of DFA. Can you hear me clearly? Or there is some audio disturbance or something? Hello? Okay, just let me know if everything is fine. Okay, okay, things are fine. So let's get started. Now, let me just tell you that this is most amazing and most needed. Okay, I mean, both are the things are there. So it is most amazing concept that we are going to study in compiler design and most needed also. And most needed. Okay, so if you understand that, then your bottom up parsing will be crystal clear. Okay, what is this rerun of DFA? If you understand that, then your bottom up parsing will be crystal clear once you understand this completely. Okay, bottom up parsing will get crystal clear. Okay, so let's just start. So what do I mean by rerun of DFA? So in the previous few classes, we have solved few questions, right? We have solved few questions regarding the LR0 automaton. So I have taken those screenshots only. So for example, we have already drawn the LR0 automaton for this particular grammar, right? Do you remember? Okay. Now what we want to do today, we want to understand this DFA. Have you understood this DFA? Tell me. See, till now what you have done. Till now, if I just give you, given a grammar, if I ask you, given a grammar, if I ask you whether this grammar is LR0 grammar or not, then can you tell me? Can you tell me whether this grammar is LR0 grammar or not? If I ask you whether the given grammar is SLR1 grammar or not, then can you tell me? Okay. I think you should be able to tell whether the given grammar is LR0, whether the given grammar is SLR1 or not, right? I mean, given the grammar, I hope you can recognize whether there is a conflict or there is no conflict, right? But we need to understand the DFA. See, understanding the DFA is actually different than recognizing whether the grammar is LR0 or SLR1. So basically, this thing is known to everyone. Everyone means almost all the aspirants might be knowing that given a grammar, how to check whether it is LR0, whether it is SLR1 or not. But there will be extremely very less fraction of students which might be knowing that how to understand this DFA, how to understand this LR0 automaton. Okay, so now we want to understand this LR0 automaton clearly. Is the objective clear to everyone that what we want to do? We want to actually understand that, right? Okay, now as objective is clear, now let's just proceed further that how we can achieve this objective to understand the LR0 automaton clearly. So see, let's suppose that this is the automaton that is given to us, right? Or we have drawn this. Okay, so let's suppose that this is the automaton that we have drawn. Now we want to understand this clearly, that what this automaton is doing actually, right? Okay, so let's just try to understand. Suppose they give me some string. Let's suppose they give me some string A. Okay, I want to pass this string A. Have you seen the previous videos where I have told you that how to parse using the stack? I mean, how to use the stack. Have you seen the previous video where I have shown how to use the stack, right? So if you have not seen, then I will put the link in the description. Okay, you can check there. Okay, so now let's suppose that this is a dollar. Now let's suppose this is the string that I want to parse. Okay, now what will happen? See, if let's see what will happen using this automaton. So what will happen? Like, so first you will say that A comes. Now the vertical bar is basically representing that what is in the stack. So it is basically in the stack. It is yet to read. Do you remember this convention? Do you remember this convention that this is in the stack and this is yet to read? Okay, I hope you remember that convention, right? Now this A is in the stack. Now what does this mean? That when you are shifting this A, okay, when you are shifting this A in the stack, then it is saying that you are going. Let's suppose this is state 0, this is state 1, this is state 2, this is state 3, this is state 4, this is state 5. Okay, so whenever you are using this A, then what does this mean? It means that you are basically going from state 0 to state 3, isn't it? Let me know. Let me know if that is fine to everyone. See, this state 0, whenever you are consuming this A, right? Whenever you are consuming this A, then it means that you are always starting with the state 0, and then you are going from state 0 to state 3, right? So So if someone asks you that if stack is containing A, then in which state you are in? Okay, basically there is a one-to-one correspondence, which means that whenever a stack is having this A, then you are in from 0 to 3, right? You are in state 3. Okay, anyway, now what you will do, can you tell me how to parse? Now you will shift one more. Can you reduce this A to something? We have already seen these things, right? Can you reduce this A to something? I don't think, right? I don't think you can reduce this A to something. So that's why you will shift one more time. Now, what is your stack containing? Your stack will be containing this. Now, that's why you will say that now this A will get reduced to S. Now your stack will be containing this. Okay. So basically, I'm making the things that stack will be containing. So first your stack will be containing A, and then next your stack is containing A, and then this dollar is yet to read. Then your stack is containing just S, right? Is this fine to everyone? Is this fine? Okay. So now what you will do? You will say this is the accept, right? I mean, you will just accept it, right? You will say this is the accept state. Is this fine to everyone? Now you will say this is accept. So what is the role of this automaton that we want to understand here? Now let's just see. See, if this A is in the stack, then you are in which state? You are in state number 3. Is this okay? Now, one more age coming, then you are in which state? See, the age coming, then one more age coming, then you are in which state? You are in state number 4, right? Now you are in state number 4. So now, interestingly, in state number 4, you are reducing this to S, right? You are reducing this to S, which means that you are saying that now the stack is containing S only. Okay, now the stack is containing S only. So in the state number 4, you are reducing this A to S. Now, can anyone tell me if stack is this? If stack is this, now you are in which state? Now, can anyone tell me now you are in which state? See here, can you tell me the state? State is 3. Here, can you tell me the state? State is 4. Now, here, can you tell me the state? Then which state it is? State is 1 actually. So basically, if S is coming, then you will go to 1. Okay. Consciously or unconsciously, you just did one thing. Can anyone tell me what is the thing that you did? You rerun your DFA, which means if A is coming, you are here, that's fine. Then if one more A is coming, you are here. Now for this S, aren't you rerunning your DFA? Or you are just starting from where you have resumed last time? See, the last stage is 4, right? Last stage is 4. Now if capital S is coming, okay, if capital S, I'm saying now after that capital S is on the stack. Now aren't you rerunning your DFA? So let's just rerun the DFA every time. Okay, let's not worry about the previous states. So here if you just run the DFA, then if only A is there, then what is the state? 3. Now if A is there, okay, don't worry about the previous thing. A, let's just rerun it again. A, then what is the state? 4. Now only S is there, then what is the state? S is there, what is the state? 1. So you need to rerun your DFA every time. Is this a little bit clear to everyone or not? We will solve many examples. I will make sure that this is crystal clear, because it is extremely important. So what we are doing, given any configuration, okay, see, we will be giving any configuration such that something is a part of a stack, right? Something is a part of a stack, and something is yet to read, isn't it? Yet to read. Something will be the part of a stack, and something will be yet to read. So we will be basically solving. I mean, we will be having these kind of states, right? States in bottom-up parsing. Okay, something will be the part of a stack and something is yet to read. Now, if I tell you, if I just ask you, then which state is the automata agent? Then what can you say? You can just run the DFA on this stack, right? So if I ask you that if the question is at which state the DFA agent, right? DFA agent. Then how to answer this question? Just run DFA on stack input, isn't it? Okay, let's just solve more questions and let's just see that if you can answer or not. Suppose this is given to me. Now, can you parse some string? Let's just take some string. Okay, let's just take some string. Can you parse the string? Let's suppose A C B B. Can you parse this string? Can you parse this string? Tell me. Okay, can you try to parse this? See, what will happen if you parse? This is ending with, let's suppose, some special character dollar, right? Now, what will happen? That this A is there, right? This A is there. Now you will say, on this A, what you will do? You will shift, right? There is no reduction even possible. Then on this next A, so you will shift. So your stack will be containing this, right? Okay. Now tell me which state you are in. Okay. Currently, which state you are in? Can anyone tell me? If you are shifting like this, then which state you are in? You will be in the, let's suppose this is state number 0, this is 1, okay, this is 2, this is 3, this is 4, this is 5, this is 6. Now can you tell me which state you are in? After this, after reading this A, so you will be in the state 3, right? Yeah, so you will be in the state 3. So you will say that if this A is there, then you will be in the state 3. Now, if one more A is coming, you will say that, okay, let's shift it. So you will be in which state? You will be in which state now? After this, still 3, right? Still 3. A. So still 3. Okay. Now you will say that, okay, let me do one thing. After this, I will be having something like this, right? So let's just do one thing. Let's just shift to the C also. Okay. On shifting the C, what you will do? What you will do? So this is from here to here, then from here to here. On shifting the C, what you will do? You will reduce, isn't it? So you will reduce the C to capital A. Now you will reduce the C to capital A, and that's why you will go to something like this. Your stack will be containing something like this, right? Your stack will be containing, let me write something like this, capital A. And then now, okay, now if I ask you that which state you are in, okay, now if I ask you which state you are in, can you tell me? Small a, capital A, small a, capital A, which means small a, and then capital A. You will be in the state 4, right? Here you are in the state 4. So what you are essentially doing? You are rerunning your DFA, isn't it? So you can say here I was in state 3, and then after the C, I'm in state 5, and after this A, I'm in state 4, right? So how to get this state 4? You can rerun. You can always rerun. Small a, and capital A. You are in state 4. Like that, you can always rerun your DFA, right? And now, okay. So what you will do? You will shift this B again, right? So which means your input will look like this. Now can you tell me what you will do to do this A, B? I think you will reduce that to capital A, isn't it? So you will reduce that to capital A. So which means if I just ask you that how your stack will look like, you will say this will look like this, right? Which means that you will be having a reduction here. Now, since you have the reduction here, can you tell me now, in this case, can you tell me what is the state? What is the state if you are having small a, capital A? What is the state? Can you tell me now? Small a, capital A. What is the state? State is 4. Yes. So again, the state is 4. And then now you are getting B. So if you are getting B, then what you will do? You will say that this is small a, capital A, small b, and then ending with dollar. So this is your stack will look like. And then can you tell me what you will do? Okay, first of all, tell me in which state you are in. In which state you are in currently? Small a, yes, small a, capital A, and then small b. You are in state number 6. Yes, Sujit, that is correct. Yes, Devansh, that is correct. So you are in state number 6. Now this is capital A and then dollar, right? Now can you tell me you are in which state? Here you are in which state? You are in state number 1, right? And then if dollar is coming, then you will say that it is accept, right? It is accept. Let me know if you have understood that how to check the state. Okay, stack is okay, but you should know that in Automata which state we are in. Okay, can you tell me which state we are in now? Given anything, can you tell me which state we are in? I think you can definitely tell, right? Let's just do one more example, and then let's just see if you can definitely tell or not. Okay, let's just see this. So let's see this particular example where let's suppose I want to parse some string. You can take any string. Let's suppose I take some string which happens to be maybe id. Okay, maybe id plus this, and then id plus ID. Okay, let's take this string. Is this string part of the grammar? So E plus this in bracket, can I write E? So I think this is a part of the grammar, right? Now tell me what will happen. Okay, at step by step. Once you consume this ID, you are in which state? You are in state number 3. Now after that, you will be having something like this, right? Isn't it? You will be having E and then this plus and the same thing, ID plus ID, right? You will be having something like this. Now can you tell me you are in which state? Now can you tell me you are in which state? Now you are in state number 1, right? Now plus is coming, what will happen? Now plus is coming, E plus, then this ID plus ID. Now you are in which state? E and then plus. You are again in state number 4, right? Here the state number is 4. So here the state is 4. Okay. Now let's just do one thing. Let's just shift it one more time. So it will be E and then it is, sorry, E plus open parenthesis and then ID plus ID, right? Bracket. Now you are in which state? You are in state number 5. Now what you will do? You will, so basically, actually, like we will relate it with the parsing algorithm, but for now I just want to tell you that how to relate with the state, like you are in which state or not. Okay, so you should know that you are in which state. Okay, so here, can you tell me now you are in which state? So E and then plus and then open parenthesis and then ID. Okay, and then if ID is coming, then you are going to state number 3, I think, right? So I think you are in the state number 3. Now what you will do? You will do a reduction in this state. What is there? You can do the reduction, right? Okay, so you can reduce this ID to capital E. Now if you reduce this ID to capital E, then what will happen? So it will be E plus open parenthesis capital E, then plus ID this. Now can you tell me you are in which state? E plus open parenthesis, E plus open parenthesis capital E, and then capital E. So you are in state number 6, right? You are in state number 6. So that's how you can keep on telling me the states, right? So let's just quickly finish this particular example. Okay, so here is the state number 6. Then what you will do? You will again do the shift, which means E plus, this is E, and then you will again do the shift. Now you can tell me the state number, right? So from 6, if I think plus is coming, then you are in the 4, and then if open parenthesis is coming in from the 4, then you are in the 5. Okay, then you are in the 5, and then if ID is coming, okay, from this 5, if ID is coming, then you are in the 3. Now you can do the reduction. So basically, so here you can do the reduction. So let's just do the reduction. And so what you will be getting after the reduction? So this will go to E plus, just a second. So it is E plus open parenthesis, E plus open parenthesis, and this ID will be what? This ID will be capital E, right? And then can you tell me in which state you are? See, let's just rerun the DFA. Capital E plus, and then from this open parenthesis, then capital E, then plus, then open parenthesis, then capital E, right? So I think you are in the state number 6, right? So if this is given to you, then you can tell me the state. So you are in the state 6, right? You are in the state 6. Now if the closing parenthesis is coming here, now if the closing parenthesis is coming at this state, so can you tell me what state you are in currently? So from this 6, if closing parenthesis is coming, so you can say you are going to the state 7. Now here, can you tell me in state 7 what is there? E plus this thing, right? E plus this thing. So can you reduce this in the state 7? Can you reduce this to capital E? Tell me, can you reduce this to capital E? Because you are in state 7, right? So you can reduce this to capital E. I mean, it will depend whether it is LR0 or SLR1. Okay, so So you are in the state 7, it is giving you the option to reduce. Now if it is SLR1, it will take a call based on the next symbol. It is LR0, it will definitely reduce, right? But let's not worry about this parsing algorithm. I just want to tell you that how to check whether which state you are in. Okay, so this will get reduced to capital E. Now can you tell me you are in which state? Okay, now can you tell me you are in which state? This is what you have, right? Capital E plus capital E, and then after that plus, and after that open parenthesis, after that capital E. You are in state number 6, right? You are in the state number 6 now. Now if the closing parenthesis is coming, you are again in the state number 7. So let's end with the dollar. So now if the closing parenthesis is coming, now can you tell me you are in which state? You are in which state now? You are in the state number 7, right? With this, you are in the state number 7. Now, in the state number 7, you can reduce this to capital E, right? You can reduce this to capital E and then, right? So you will say this is now you are in which state? Now can you tell me you are in which state? You are in the state number 1. Now you will say that okay, if dollar is coming, this is accept basically. Okay. Now after that, if dollar is coming, so you will say it is accept. Isn't it? Okay. Understood that how to parse using the states, that how to map the states, and how this automata is working? Little bit, most probably little bit you have understood, right? Now let's just solve more examples. Okay, now maybe I can give you. Okay, let's just take this, or maybe let's just take this. Okay, let's just take this. Can you tell me here let's suppose I want to parse something. Okay, let's suppose I want to parse the string which is a. Let's suppose, let me write the string here. The string is a b a b. Okay, a b a b. So what will happen? You will say that okay, first you are basically ending with the dollar, and then you will say this. So from this small you are in state number. This is this visible? This is 4. This is 3, right? This is 3. This is 1. This is 2. This is 5. This is 6. This is 7. Okay. Now can you tell me you are in which state? You are in which state? State number 4. And then on double A you are in which state? If double A is there, then you are in which state? Can you tell me? Again state number 4, I think, right? And now if on this state number 4 there is no reduction, that is okay. Now if small b is coming in this state number 4, then what you will do? You will say that okay, a small b is there, and then ab dollar, right? Now can you tell me you are in which state? Here, can you tell me the state number? State 6, right? State 6. So this is state 6. Now this is a b is the state 6. Now can you tell me what is there in the state 6 to do? State 6 is saying you can reduce that to capital B. Okay, you can reduce this small b to capital B. But will you blindly reduce, or based on the parsing algorithm you will reduce? Tell me. Based on the whether it is LR0 or SLR1, right? If it is LR0, you will blindly reduce. If it is SLR1, you will check whether this next symbol, which is small a, is this the follow of capital B? Capital B follow is having small a or not? Yes, it is having, because it is having first of capital B. So that's why you will reduce, right? I mean, if it is SLR1, you will just take care of the follow. Otherwise, you will blindly reduce given the state. Okay. Anyway, this will get reduced to capital B. Now, can you tell me you are in which state? Here you are in which state? Can you tell me you are in which state? A, and then capital B. You are in state number 7, right? This state is 7. Okay. Now this 7 is having something to offer. So what reduction it is offering? Small a capital B can go to capital B. So this top of the stack, right? Okay. So this can go to capital B. So you will say this will go to capital B, AB, right? Okay. Now you are in which state? Can you tell me? Can you tell me you are in which state now? A and then capital B. Again 7, right? Again 7. So you are in again state number 7. Does this state 7 have something to offer? Yes. So what it is offering? It is offering a reduction. So based on the whether LR0 or SLR1, you will do the reduction. In LR0, you will do the reduction blindly. In SLR1, based on the next input. Suppose it is SLR1. Will you do the reduction or not? Tell me. Is this a follow of capital B? Is this the next input symbol in the follow of capital B? Yes. So you will do the reduction, right? So B and then AB. Okay. Now you are in which state? Can you tell me? Now you are in which state? capital B, AB. Capital B is coming, right? This, the state number is 3. So this state is 3. Okay. And now this capital B, and then if A is coming, so 3 doesn't have anything. So if A is coming, you will go to 4. So from here, you will go to this. So, and then from here, you will go to this. So now can you tell me you are in which state? Capital B, A, and then B. You are in state number 6. Does this have anything to is to offer? Reduction does this offer reduction? Yes, right? So it offers a reduction. So basically you can reduce that to capital B. So which means you will say that this is capital B, small a, capital B, right? Dollar. Now can you tell me you are in which state? BAB, right? B, A, and then capital B. You are in state number 7. Does this offer a reduction? Yes, AB. You can reduce that, right? AB to capital B. Okay. Now can you tell me you are in which state? Here you are in which state? Can you tell me you are in which state? BB. BB. You are in state number 5. Can you reduce? Yes. S dollar. Now can you tell me you are in which state? Can you tell me you are in which state? You are in the state number? Tell me. You are in state number 1. So it is a accept, right? It is a accept. I hope you understood. Let me know if there is an issue. Now let's just solve more questions of the MSQ type, okay? Of the similar format, but the type will be the MSQ. Let's just see more questions. Okay, so now these are the previous examples that we have taken in the last class. So let's directly jump to the MSQ questions. Okay, can you solve this question? Suppose this automaton is given to you, and then what they're asking is that they are saying that if this automaton is given to you, consider the LR0 automaton that is given to you. Okay, suppose the parser is in the state 5, then what are the possible contents on the stack? Suppose the given parser in the state 5, then what are the possible contents? That's what they're asking, right? Okay. Can you try solving this? See what is happening here, that they're asking the possible content on the stack. If you're in the state 5, then how you can come to state 5? Maybe you can come directly, maybe C. Okay, maybe C is the only thing. Can you see this state 5? Is this visible? Okay. So what is the content on the stack? Maybe only C. Can B B C 3 times B and C be the stack if you are in state 5? So if you're in the state 5, then B C. Yeah, that is true, right? That you could be having this in the stack. You could be having this in the stack. The top of the stack must be C. Is this true? If you're in the state 5, then obviously the top of the stack must be C, because it is before dot, it is C, right? See, if let's suppose you are in let's suppose some state which is having x gives alpha dot beta. If you are in some state which is having x gives alpha dot beta, what can you say about the top of the stack? Top of the stack must be alpha, right? There may be other things about it. See, let's suppose you are in some state which is having x gives alpha dot beta. What can you say about this state? Okay, what can you say about this state? Say about this state. It must represent that alpha must be on top of the stack, right? Must be on top of the stack. Okay, let's suppose they give you something. They give you something like this. E gives E plus, or maybe let's suppose some other grammar, maybe S gives A S dot B, or maybe S A dot B, let's suppose, and let's suppose B gives A dot. Okay, if there is some state something like this, what can you say about this state? What can you say? What is on the top of the stack? Looking at this state, what is on top of the stack? Top of the stack is A. Can you tell me more? What is top of the stack? Is SA also. Okay? Because of the SA, you are coming here, right? because of the SA. So top of the stack is A, that is fine. But can you tell me more? Yes, SA is also top of the stack, which means there might be something in the stack then S then A. Okay, there might be something here. So if you are in this state, then you can definitely tell me that S is on the top of the stack. Okay, I mean, or you can also say that A is on the top of the stack, but if you want to tell more, you can say S is on the top of the stack, isn't it? Okay, now you tell me about this. That if you're in state 5, this is the state 5, okay, then maybe BBBC is leading you to the state 5. Is C in the top of the stack? The top of the stack must be C. Is this true or false? This is true or false? This is definitely true, isn't it? Because you are in the state 5 and C must be on the top of the stack. The stack content could be BC. Can it be BC? BC, and from here there is no even B move, right? Stack can never even contain this BC, right? Stack can never even contain this BC. So to reach this state 5, can the stack content be the BC? Tell me. No, right? Can it be BSC, BS, and then C? No, right? So that's why this is also false. So these two strings are not leading to state 5. Understood? Okay, maybe you can solve more examples and then tell me what is happening. Suppose there is some state that is given to you. Maybe, okay, there is some mistake that is given to you, ASA and something like this. So what can you say about this state? Content of the stack. What can you say? If you are in this state, what can you say about the content of the stack? We cannot say anything about the top of the stack, or the top of the stack must be A, must be C. What is your answer? If someone tell you are in this state, then the top of the stack must be. What is your answer? It must be A, right? Yes, it must be A. Why that is the case? Because you are saying here that this is A dot, because dot is after the same. It means the top of the stack must be A. Okay, so you're using this, you can definitely infer that what is the top of the stack. Okay, cool. Can you say that the content, the stack content, can you say the stack content is only A? Stack contain only A? Is this true? Is this true? The stack only contain A if you are in this state? No, right? No. Whatever is the initial state, from here you might have reached there. And first of all, it is by the way self loop. So there could be multiple A's first of all. And also, whatever is the initial state, you might have reached using some path. It must also contain all of this, right? Stack must also contain all of this. Okay. Now let's just solve this. Suppose they say this, consider the 3 LR0 items given of an unknown grammar. What can we say about LR0 items? So item 1 and item 3 could be part of some LR0 automated state. Can you say that 1 and 3 could be part of only one state? Can 1 and 3 be the part of only one state? Are they meeting the criteria? See, one is saying if that is there, then one is saying that top of the stack is small a, and this is saying the top of the stack is small c. Can they be the part of the same state only? Can they be the part of the same state? Tell me. Think about it. Can they be the part of the same state?
Yeah.
No, right? No. So yeah, why? Because here this A is saying the top of the stack is A, right? And this C is saying the top of the stack is C. So that is why both cannot be the part of the same state. So that's why this is true or false? Tell me. This is false. Can 1 and 2 be the part of the same state? 1 and 2. What do you think? Again, no, right? Why? This is saying top of the stack is capital B. This is saying top of the stack is small a. That's why, right? Can 2 and 3? Can 2 and 3? Tell me. Can 2 and 3 be the part of the same state? Okay, these are the easy questions. You should be able to tell me quickly. See, this 2 is having this B, this is having C. So obviously no, right? No, no. These 3 items must belong to different LR0 automaton state. Is this true or false? Yeah, that is true, right? Okay. So I hope you understood, okay, that how to solve this. Okay. Now let's just solve more questions. Can you solve this question? Just take your time and solve this question. Okay, let's suppose this is the current state. Okay, whatever is the number, let's suppose this is the current state. Then what can you say? The stack content could be r plus x, where x is on the top of the stack. Can the stack content could be r plus x if this is the state you are in currently? Tell me. So what is the correct answer? A is the correct answer. Yes. Okay. And what else? Because using r plus x, you can definitely go here. The stack content could be r plus x plus r plus x, r plus x plus, there is no plus move defined here. So this is not the answer. Can the stack content be just x? Yes. The top of the stack must be x. Yes, it must be x, right? So that's why ACD is the correct answer. Yes, every one of you have given the correct answer. That's really good to see. So maybe I can just show here also that every one of you has given the correct answers, right? Okay. Okay. So now let's just move to the next question. Can you solve this question? What they are saying, that this is given, then which of the following can never be the content of the stack? Which of the following can never be the content of the stack? Can you tell me? This BB, can this never be the content of the stack? This BB, just think about it. It can be, right? It can be the content of the stack, definitely. BB, and if B is coming, so since there is no move defined, so you, in which state you will go? There is no state, right? So after BB, you will reduce that to S. If BB is coming, you will reduce that to S. You will not be doing the shift. Basically, if this B is there or something, then you will not be doing the shift. So after this BB, you will be just reducing. So that's why this can be the content of the so this cannot be the content of the stack. So that's why this is the answer. BAB. What about BAB? BAB can be, right? BAB can be. AB. What about AB? A and B. This can be. So only B is the correct answer here, right? Even though this is MSQ, still only one is the correct answer. Okay. So these kind of nice questions can be framed. Now, can you solve these kind of questions? Okay. Can you confidently solve these kind of questions? Can you solve this question now? Consider this LR0 automaton for the grammar. If parser is in state 4, then what can you say about the possible content of the stack? So if you are in the state 4, then what can you say? The possible contents, can you tell me? The stack content could be E plus. It could be E plus. Is this true? Yes, right? It could be E plus if we are in state 4. Yes, that is true. It could be ID plus. Can it be the ID plus? Tell me. No, after ID you will be reducing, and then it cannot be the ID. So ID plus can never be on the stack. Can it ever be on the stack? Ever? Can it ever be on the stack? Forget about you are in state 4 or anything. Can it ever be on the stack? Whenever ID will be coming, you will be reducing it to E, right? It can never be on the stack. You won't be shifting the plus. So if ID is coming, and then let's suppose plus or something, first you will reduce that to capital E, and then you will be shifting the C. So E plus can be on the stack, but ID plus can never be. Okay, ID plus can never be on the stack. Forget about any state or anything. So ID plus can never be on the stack. Okay, so what is the answers here? ID plus can never be on the stack. Stack content could be E plus, open bracket, E plus, and then open bracket, E plus. Yes, stack content could be ID plus. No, stack cannot be having ID plus or something, because after ID you will be reducing. So that's why no, right? So 1 and 3 are the correct answers here. Okay, understood? Okay, okay. Now let's just move to the next question. Can you tell me, if you are in state 3, after reading up, that's really interesting. They are saying that a parser in the state 3, after reading a part of the input that is in the state 3, then what should be the remaining input such that the input string finally get accepted? So they are saying They are saying there is something on the stack, and then you are in state 3. Okay, what is in the stack? They haven't told you. Okay, maybe you can figure it out, but yeah, they haven't told you that what is in the stack. Okay, they are saying that you are in the state 3. Then what should be there in the remaining input? What should be there in the remaining input such that that finally get accepted? Tell me. This is a nice question, isn't it? So what should be there in the remaining input such that it finally get accepted? Let me know. Okay. So see, if you are in state 3, first of all, that will be capital B only, right? Because you can easily figure out it should be capital B. Now what should be there? Or even you do not figure out, then see, from this state, you want to reach to the accepted state finally, right? You want to reach here. So if a small b is coming, you can reduce this. You can reduce this to capital B, and then from see you, okay, let me just solve it in one easy way first. So can you infer that what will be in the stack? In the stack, it must be capital B only, right? Because you are in the state 3. And now since this is there, so basically you can figure it out that one more B is remaining, right? Which means B means A, and B, right? So one more B means anything A star and B, basically. So maybe you can have this, you can have this, you can have this, right? So I think A, B, and D are the correct answers. If B is there, if a small b is there, then also if you are in state 3, if a small b is there, then you will go to state 6, then you will do the reduction, and after reduction, can anyone tell me where you will be? So my question here is that suppose you don't know this, okay, that what is in the state 3. You just tell me that if a small b is coming, then after the reduction there will be capital B, isn't it? Now where you will go after this reduction, then when you reduce this to capital B, where you will go? Okay, where you will go? No, see, you are in the state 3. Now if you are in the state 3, small b is coming, you will do one thing. You will say, see, you will say something like this, that you are in the state 3. See, you will say something like this, you are in the state 3, and if let's suppose a small b is coming, okay, a small b is the next thing, then you will push this, okay, you will push the small b, and whatever is there, okay, that will be here. You will push the small b, isn't it? You will go from here to here, then you will go to 6, and then after the reduction, if you reduce that to capital B, then where you will go? That is my question. Currently, if this is the state 3, if this is the state 3, now you just tell me which state this is. See, this is the state 3. So whatever it was, you will consume that and you will be in the state 3 again. You just need to consume capital B, okay? You just need to consume capital B, and then you will be in the 5. So here you can definitely say you will in the 5, right? You will in the 5. Okay, state 5, isn't it? Okay, so it will be in the 3. Just because of this, it will be in the 3, because it was in the 3 because of this. Now you have the capital B. So from 3 you can resume, right? From 3 you can resume. So that's how also you can solve this particular question. So that's why you will say it is in the state number 5. Is this okay to everyone? Let me know. Okay. Now can you solve this question? Okay, so see, in this question they are saying you are already in the state number 3, which means top of the stack must be capital B, right? Must be capital B. So you have seen this capital B, you are yet to see one more capital B. So capital B means A star B. So whatever is the A star B, that will be the answer, right? So that's why A, B, this is A star B, this is A star B, this is also A star B. So that's why these 3 are the correct answers here, right? Understood? Okay, great. Now let's just answer this question. Maybe you can answer these questions. Okay, what are the possible content of the stack? Cool. Now, can you answer this question? This question has been asked in GATE 276. So what they are saying, that if this is given, consider the following LR0 items corresponding to the above grammar. Okay, if you notice that this dot is here, this dot is here, this dot is here. Now they are saying, given these items, which of the following them, which two of them will appear in the same set? Okay, just tell me. So which two will appear in the same set? That's what you need to tell. See, here, if you just look at this, what does this tell you? What does this tell you? Any of this dot, what does this tell you? What does this dot tell you? This tell you top of the stack must be this, isn't it? This tell you top of the stack must be this. This tell you top of the stack must be this. Are they basically agreeing on anything? Tell me. No, right? So can they be part of the same state? No. So that's why none of them. Understood? Okay. Okay. Now let's solve more questions. Now, okay, I hope you can solve these questions. Now let's just move to the next topic, which is Bible prefix. Okay. You notice one thing, that in the stack, if I just ask you that in the stack ID plus, can this ever appear in the stack? Can this ever appear in the stack? In this particular grammar, can ID plus ever appear in the stack? Do you think? No, right? Because whenever ID is coming, you will reduce it to capital E and then only you will shift it. You will not shift it without reducing, right? So it can never appear on the stack. So there are few things that can appear on the stack. There are few things that can never appear in the stack. So if I just ask you, what are the things using this? Okay, using this, what are the things that can appear on the stack? Then can you tell me? So suppose if I just ask you that what are the things that can appear on the stack? Then can you tell me? Okay, just tell me, can E appear on the stack? Can ID appear on the stack? Can E plus appear on the stack? Can E plus plus appear on the stack? Okay, let's suppose this is 1, this is 2, this is 3, this is 4, this is 5. Can E plus bracket appear on the stack? This is 6, let's suppose E plus bracket E, can this appear on the stack? So, so just tell me, okay, just tell me, can just closing parenthesis appear on the stack? Can just let's suppose closing parenthesis and then let's suppose E, can this appear on the stack? So what are the things that can appear on the stack? Can you tell me? Can E appear? Yes, because that is leading to the valid state. Okay, E appear, yes. Okay, and what about ID? Just ID can appear. E plus, can this appear? Yes, because that is leading to the valid state. So basically, what does this valid state tell you? It means that there's a hope. There's a hope that there is something that can come. Okay, there is something that can come, and ultimately it can reduce to the start symbol, which means here you, as long as you are in some state. Okay, as long as you are in some state, here E plus. Okay, E plus. Now this is giving you some hope that okay, maybe something can come now that can eventually reach to the accepted state. As long as you are in some state, there is still a hope. Okay, so E plus, yes, this can appear. E plus plus cannot appear. E plus, this can appear, this can appear, this cannot appear, this cannot appear. Okay, understood? So if I just ask you that what can appear, what cannot appear, it means you can just tell me whether it is leading to the valid state or not. So if someone asks you what can appear in stack, then what you need to do? Then we just need to check. We just need to check whether it is leading to the valid state or not, right? Whether it is leading to valid state or not, isn't it? Is this okay to everyone? So here can this just closing parenthesis appear on the stack? Can this just closing parenthesis? See, on the closing parenthesis, there is no move. You have to rerun the DFA, right? There is no move. Okay. Can this be just stack content? Can this be just a stack content? No, right? There is no move on the closing parenthesis. Okay, from this initial state. That's why it can't be the stack content. Okay, so which of the following can be the stack content? Which of the following can be stack content? Okay, if there is a move down, then only the parser always run this DFA. Okay, parser always run this DFA. So if there is a move, then only the parser will run. Otherwise, parser will not run, isn't it? So that's why you will say that there's someone asks you that what can appear, what cannot appear. I can just check whether it is leading to the valid state or not. Okay. Interestingly, what can appear on the stack is basically called viable prefix. Okay. Now, if someone asks you that given this, okay, given this automaton, let me just ask you which of the following can be the viable prefix? Which of the following can be the viable prefix? Can you tell me which of the following can be the viable prefix? Let's suppose option A is capital E, option B is ID, option C is ID plus, option D is E plus, option E is E plus, let's suppose E, option F is E plus open parenthesis, option G is plus open parenthesis, option H is, okay, let's suppose option H is ID plus open parenthesis, option I is maybe something like that, maybe E plus open parenthesis E. So what are the answers? Which of the following can be the viable prefix? What is this viable prefix? Something that can be the content of the stack, right? Something that can be the content of the stack. So can E be the content of the stack? Can E be the content of the stack? So what is the viable prefix? Viable prefix means something that can be the content of the stack. Something that can be content of a stack, right? Content of a stack. So this A can be the content of the stack because it is leading to the valid state. ID can be the content of the stack. ID plus cannot be because it is not leading to the any valid state. ID plus there is no move. So E it can be. This E cannot be because E plus E there is no valid move. E plus open parenthesis, yes, this can be. Plus closing parenthesis, plus open parenthesis, there is no move, right? Starting from plus. So no, there is no. This could be yes, right? So these are the viable prefix, right? Viable prefix is what? That can appear on the stack. Okay. Okay. Is this definition a little bit clear that what is a viable prefix? We will make it more clear, but is this little bit clear that what is a viable prefix? It is basically whatever can appear on the stack. Okay. So which means if I tell you the stack content is, let's suppose if I tell you at some point in time stack content is alpha 1, or maybe let me write like this, okay, alpha, beta, gamma, delta. Let's suppose this is the stack content at some point in time. Then what are the possible viable prefix? So can you tell me, can this be the viable prefix? Alpha, beta, gamma, delta. Can this be the viable prefix? Can beta, gamma, can this be the viable prefix? Can let's suppose alpha, beta be the viable prefix? Can alpha, beta, gamma be the viable prefix? Suppose this is MSQ question. So what is your answer? What is your answer? See, this can be the viable prefix. This can be, this cannot be. Why? See, let's just understand. What is the viable prefix? What is the viable prefix? Anything that can appear on the stack, right? Anything that is stack content. Anything that can be stack content. Stack content. Now, suppose someone give you the stack content is alpha, beta, gamma, and delta. Suppose someone gave you this is the stack content, okay? Suppose someone give you something like this. Now you tell me at some point in time, see, someone tell you at t equal to, let's suppose 10. That is the extra content. Isn't it possible that at t equal to 5, the stack content would be little lesser? You must have built it incrementally. Can the stack content be this at before time? The stack content could be this. Tell me, could have been this, right? Stack content could have been this. Then you might have added this gamma and delta, right? So basically, what I'm saying that if this is the stack content, then this was also the stack content at some point in time. This was also the stack content in some point in time. This was also the start of the content of the stack at some point in time, and this is the stack content currently, isn't it? So whatever is the prefix of the stack content is also the stack content, right? See, the prefix of the stack content is also the stack content, isn't it? Tell me, is this true or false? The prefix of the stack content could have been the stack content earlier, right? So prefix of stack content was the earlier stack content, isn't it? Let me know if that is okay to everyone. This is okay, right? Prefix of the stack content was the earlier stack content, something like that. So basically, you can say if this is the stack content, then alpha could be the stack content. Only alpha beta could be, alpha beta gamma could be, alpha beta gamma delta. But beta gamma was never the stack content, right? Was never the stack content. So it is not the Bible prefix. Stack content and Bible prefix is same. Okay. See, if someone asks you the definition of the Bible prefix, then what is the definition of Bible prefix? What is the definition? Let me write the definition of the Bible prefix. Just a second. Yeah. So if someone asks you what is the Bible prefix, can you tell me what is this? This is same as content of the stack. Whatever can appear on the stack, that is a Bible prefix, right? And content of stack. Now, can you tell me? Can't you recognize what is possible content of the stack? If I just give you some automata, then can you tell me which of the possible is the content of the stack? Can you just rerun the DFA and can you see if it is leading to the valid state or not? Isn't it? So, given something, can you tell me it is a Bible prefix or not? All you need to do, just run the DFA, right? All you need to do, just run the DFA. So, what is the Bible prefix? It is just a content of the stack. Okay. So, just content of the stack is called Bible prefix. That's all. So, if I just tell you the definition formally, that the prefix of the right sentential form that appear on the stack also is called the Bible prefix. So basically, whatever appear on the stack is called the Bible prefix. Okay. See, we have done some parsing. Let's suppose int star int. Okay. Let's suppose this was a string. Then do you remember we have said like, okay, let's put the vertical bar, right? This is in the stack and this is not in the stack, right? Something like that. Now this whole thing. Okay. Let's suppose it is going to E into dollar, right? This whole thing without the bar, this whole thing is nothing but, okay, this whole thing is nothing but right sentential form only. Right sentential form. Okay, right sentential form. So whatever form we have in the bottom of parsing, that is sentential. That is the right sentential form only. Whatever form we have. See, stack content and the remaining input combinedly tell you the right sentential form. Is this okay? See, this is the right sentential form. Before this, what could have been the right sentential form? This, right? We will keep on doing this. We will keep on doing this. Okay, the moment we know the handle, we will keep on doing this. So stack content and the remaining input combinedly tell you the right sentential form. Is this okay to everyone? Let me know. Okay, let me know if that is okay. Okay. So now if someone asks you what is the Bible prefix, I hope you can tell. The set of Bible prefix corresponding to the possible stack is called Bible prefix. Anyway, so now if someone asks you, like if they are saying that give me all Bible prefix, then how can you give all the Bible prefix? What is the Bible prefix? What is the possible, right? Whatever is the possible that can come. Okay, in any valid string, whatever is the possible that can come. See, here, can the valid string, okay, or any right sentential form, can any right sentential form start with ID? Let's suppose this, maybe you can say, let's suppose if I ask you that there is some right sentential form, can this right sentential form be containing E plus? Can this right sentential form be containing E plus? Yes, because it is leading to the valid state. So basically, if someone asks you to give me the set of all Bible prefix means whatever can appear on the stack. What you need to do? Can anyone guess? If someone asks you the all viable prefix, then what do you need to do? What do you need to do? You just need to draw the DFA and just tell me the language of this. Yes. Yes. You just need to draw the DFA and tell me the language of this. Okay. For example, if they are asking you, that tell me the set of all viable prefix here. Okay. For this particular grammar, can you tell me the set of all viable prefix? Then essentially they are asking you that what can appear on the stack, right? So you can tell me that what is the automaton for this, right? And then if S is coming, it will go to something. And if dollar is coming, it will go to asset, right? Okay. Now, if 0 is coming, it will go to S gives 0.S1 or 0.1, right? And because of this, I need to write all the productions of S. This is 0S1.01, right? Okay. And now, if capital S is coming, if 0 is coming, it will be the self loop. Okay. If capital S is coming, it will go to S gives 0S.1, right? And if 1 is coming, it will go to S gives 0S1 dot, right? Okay. And if here 1 is coming, it will go to S gives 0.1 dot. Okay. What else? Capital S is done, 0 is done, here 1 is done. I think we have made the automaton. Is this okay? That how we are making the automaton? Let me know. Okay, now what they're asking the set of all viable prefixes, right? Now they're asking the set of all viable prefixes. So how you can tell the set of all viable prefixes? You just need to do one thing. What is that? You just need to tell the grammar or the language of this this particular or the regular expression of this particular automaton. See, you understand that every state, if someone asks you the viable prefix, then you understand that every state is a final state. Every state is a final state, okay? And then tell me the grammar or the language. So if every state is a final state, then can you tell me? I think epsilon will be there, S will be there, either S or maybe you can say 0 star 1. Okay, 0 star, and after 0 star, maybe 1 can occur or S1 can occur, right? Something like this. Okay, maybe you can have little better form. Okay, maybe let's just epsilon is because of this, right? Epsilon is always a viable prefix. Why? Because of this. So if every state is a final state, then you can, if you tell me the regular expression, then these are the set of all viable prefixes, right? So what is the viable prefix? Viable prefix is something that can appear on the stack. Now tell me, can S appear on the stack? Yes. Can 0 appear on the stack? Yes. So can S appear? Yes. Can 0 appear? Yes. Can 0 appear? Yes. Can 0 star S appear? Yes. Can 0 1 appear? 0 and then 1 appear on the stack? Yes. Right? All of this can appear on the stack. So which means if you take all of them as a final state, and this is the initial state, okay? This is the initial state, obviously. This is the initial state, and all of them as final state, then whatever grammar you get or whatever regular expression you get, this is the set of all viable prefixes. Set of all viable prefixes. Let me know if that is okay to everyone. Then how to find set of all viable prefixes, right? Okay, 0 1 can occur. Okay, this should be, I think this is no star here. Yeah, this is 0 and then 0 star, right? So 0, after that there will be 0 star. Okay, I think I can write like this, right? 0 and then 0 star, and then maybe 1 can occur, or maybe S and 1 can occur, right? Maybe something like this I can write. Is this the correct form? Okay, so whatever can appear on the stack is called viable prefix, right? Now let's just solve more questions. Just tell me the set of all viable prefixes forms a regular language. What do you think? This is true or false? This is true or false? The set of all viable prefixes forms a regular language. This is true, right? True. Even we can draw the DFA, or we can have the regular expression. So if someone asks you set of all viable prefixes here, then what do you need to do? You just need to draw the LR0 automaton. and tell me that what is the language of this, then this is the set of all Bible prefixes. Now this is the question for Allman. We have solved this. You can try these two. Okay, what you need to do, you just need to draw the DFA and treat every state as a final state. Treat every state as a final state. For Bible prefix, treat every state as a final state, right? Every state as a final state. Okay, and this is the initial state. Okay, now you tell me this. What are the Bible prefixes of E into this right side? Only one. You don't need to know. You don't need to count the Bible prefixes for all the right sentence form or for the grammar. For just given this right sentence form, can you tell me the Bible prefixes of this? Let's suppose this is getting derived like this. Okay, which means they are saying that E is driving in multiple steps. E is driving F into ID, and then in one step it is getting derived to into ID. Can you tell me the handle here first of all? Can you tell me the handle? Handle is this, right? This is the handle. Okay, this is the handle. Now, can you tell me if this is the handle, then what must be, if this is the right side from, I mean, that is how we are basically driving this, then what must be in the stack? What must be in the stack? In the stack, there must be only, see, till handle only must be on the stack, right? The stack must be containing this. This is the stack content, isn't it? See, for this, if you are only parsing this this particular string, okay, maybe you are parsing something and then you got this, okay, or maybe you are parsing only this particular string. Then at that point in time, you will be saying that okay, you will be pushing this, and finally you will be reducing that to capital F, right? That's how you will be doing. So you will say that this is the content of stack content. And if someone asks you what are the Bible prefix here, so the Bible prefix could be any prefix of the stack content. So the Bible prefix is this, and this. Any prefix of stack content. Any prefix of stack content. Isn't it? Okay, maybe you can solve one more question. You just tell me that if this is given to you, they are saying that S is driving in multiple steps, is driving alpha A Z, and one step you are driving alpha beta Z, right? In one step you are driving alpha beta Z, which means this beta is a handle. This beta is a handle. Can you tell me the Bible prefixes? The Bible prefixes, can you tell me? Can you tell me the stack content now? Stack content. It will be alpha beta, because beta is a handle, it should be on the top of the stack, right? So alpha beta will be in the stack, and then you are basically you are saying alpha beta and then Z. So this is in the stack, this is yet to read, something like that, right? Okay. Now what are the Bible prefix? What are the Bible prefix? Tell me. See, alpha can be the Bible prefix, right? Alpha beta can be the Bible prefix, right? Like that, right? So any prefix of beta, no. Any prefix of alpha beta, yes. Any prefix of alpha beta is the correct answer here. So any prefix of alpha beta, right? Any prefix of alpha beta Z, no. Beta Z, no. So any prefix of alpha beta. So whatever is the stack content, prefix of that, or maybe that itself is the Bible prefix, right? So that whatever can appear on the stack is actually the Bible prefix. Okay. Now let's just solve this. Okay, let's just solve this. Alpha is a Bible prefix, then we can always append set of terminals to get some right sentence form. So tell me, is this correct? Is this correct? Tell me. If alpha is a Bible prefix, see what is happening here. That see what is a Bible prefix? See, before bar, whatever is there, right? That is a Bible prefix. I mean, prefix of that is a Bible prefix basically. Then can you append some terminals to get the right sentence form? So basically they are saying if there is some Bible prefix alpha, okay, let's suppose there is some Bible prefix alpha, then can you append some terminals here? Terminals. And can you say this finally? This is a right sentential form. This is a right sentential form. Can you append some terminals? See, if it's a Bible prefix, tell me, won't it be the So it seems like I was not audible, right? Okay, so I was saying, let's suppose alpha is a Bible prefix, okay? Why alpha is a Bible prefix? Now, which means that if alpha is a Bible prefix, can you tell me the stack content? Can this be the stack content? Can I say this is yet to read and this is a stack content and alpha is a Bible prefix? Can this be the correct reasoning? If alpha is a Bible prefix, then I might be having this in the stack and this is yet to read, isn't it? If alpha is a Bible prefix, can I just have this on the stack and this is yet to read? If alpha is a Bible prefix, then there will be some time, there might be some time. See, currently alpha is a Bible prefix, maybe today, okay? Maybe let's suppose today, but 1 hour back, 1 hour back, 1 hour back. If I just go back in the time, then can't I say that alpha was the only stack content? This is yet to read. Alpha was the only stack content 1 hour back. If it is a Bible prefix, then it was the only stack content few time later, isn't it? Tell me. Few minutes back, it was the only stack content. Is this possible? It was, right? It must be. If it is a Bible prefix, then it was the only stack content few minutes back. Now there might be something I posted alpha is still a Bible prefix, but I'm saying that if it is a Bible prefix, then sometime back it was the only stack content, isn't it? Now if this is yet to read, tell me if this is yet to read, this will be terminals or non-terminals? This will be terminals or non-terminals? Tell me. See, if this is yet to read, if this is yet to read, then this is terminals only, right? If this is yet to read, terminals. So what I'm saying here, that if alpha is a Bible prefix, you can always append terminals. You can always append terminals, which means alpha and some terminals. This whole thing is a right sentential form, right? Whole thing is a right sentential form. See, anything in bottom of parser where I say this bar, this, right? This anything that I say this is always the right sentential form. So can I append some terminals here to get the right sentential form if alpha is a Bible prefix? Tell me. If alpha is a Bible prefix, then we can always append some set of terminals to get some right sentential form. Tell me. Is this correct? The answer is yes. Okay, yes, that is correct. That's a very nice question. Now tell me, if alpha is a Bible prefix, then we can always append some non-terminals to get some right sentential form. Then only non-terminals. Can you always append only non-terminals? If alpha is a Bible prefix, then can you append only non-terminals? No, right? You can only append terminals. Maybe let's suppose this is non-terminal, right? This is non-terminal. Okay, let's suppose this is non-terminal. This is terminal. These are anyway terminal, but this could be mix of non-terminal terminal, because on the stack anything could be there, right? This could be mix of terminal and non-terminal. Now tell me, if alpha is a Bible prefix, then can you always append only non-terminals? Only non-terminals might not be possible, right? You can always append terminals, but only non-terminals might not be possible. If alpha is a Bible prefix, then we need to append mix of terminals and non-terminals. Alone terminals or non-terminals won't do. To get some right, they are saying you need to append mix. Do you always need to append mix? See, alpha is a Bible prefix, then you definitely need to append mix of terminals and non-terminals, so only terminals will be fine. Only terminals can give you the right sentential form, right? So it's not necessary you need to append both. Alpha is a Bible prefix, then we can append mix of terminals and non-terminals to get some right sentential form. So if alpha is a Bible prefix, then can you append non-terminal also? See, you can append something which will finally get reduced to non-terminal, and then you can say this. Yes, let me see. Let's suppose this alpha is a Bible prefix, right? This is content of the stack. Content of stack. Sorry, this is yet to read. Okay, yet to read. Now let's suppose you read small a, small b, something like that, right? Let's suppose you read small a, and from here to here you go, and then you go to capital B. Let's suppose you reduce this small a to, let's suppose, capital A. Okay. So whatever this is, let's suppose this is x. Okay, let's suppose this is x. This is x. This is x. Tell me here what you are appending in alpha to get. Okay, so this x is a set of terminals only. So by the way, what you are appending in alpha to get the reaction form? The appended thing is abx. Let's suppose this is abx. Okay, this is small x. Small x is a set of terminals only. Here, what you are appending in alpha to get the reaction form? Again, the abx, right? Here, what you are appending in alpha? Alpha capital A, small b, small x. Isn't it also the reaction form? So here in the alpha, you are appending some non-terminal, some terminal, right? So basically in alpha, you can append, always we have the option to append the non-terminal. But if we want, we can append the, sorry, always we have the option to append the terminal. But if we want, we can append the non-terminal also, like that, right? If that get reduced to something, then we can append the non-terminal also, which will be the part of the stack. Obviously, it is a part of the stack, right? Part of the stack. So we can append the non-terminal also, and then also we can get the rat form. Is this okay? Let me know. So here we can append the mix of terminals and non-terminals, and then we can go to the rational form. Okay. Let's solve this question. Which of the following strings are Bible prefix? For each of the string is a Bible prefix. Give a suffix that produce a rational form. So what you need to append so that it will be the rational form. So just tell me this. Is this a Bible prefix? Can this be the part of the stack? S plus ID equal. Can you append something here such that you finally get to start symbol? I think this is S, right? S plus. I think this, if you append S only, if you append capital S, or maybe you can append ID, right? Maybe if you append ID, then this ID will finally get to capital S, and then this whole thing will get to capital S. Then this whole thing can get to the capital S. So what are the set of terminals that you can append here to tell whether we can reach to the start symbol or not? What are the terminals that you can append? ID, right? You can append ID here. So is this a Bible prefix? This is always a Bible prefix if you can append, and then you can go to the start symbol. Which means, can this appear on the stack? Do you think it can appear on the stack? See, what is the way to check Bible prefix? You can definitely draw the DFA. But this is a long way, right? This is a long way. You can definitely draw the DFA, and then you can check whether this is a Bible prefix or not, whether it is leading to the valid state or not, right? You can definitely do it. Okay, you can definitely draw the DFA, but that will be the long way, and then you can check whether it is leading to the valid state or not. What could be the other way? You just check whether, if you append something, maybe ID, then is this reaching to the start symbol? Yes, then it can appear on the stack. So this is the Bible prefix, and what is that thing that you need to append so that you reach to the start symbol? ID. Is this the Bible prefix? Is this the Bible prefix? Tell me. Can you have starting with plus? Can stack be having starting with plus? Is this a Bible prefix? Can you anytime append something here? Can this be the bottom of the stack? See, Bible prefix is always the here. This must be the bottom of the stack, which means, see, if I'm saying something is a Bible prefix, what is a Bible prefix? The content of the stack, right? Or the prefix of this. So what are the Bible prefix here? Alpha is a Bible prefix, alpha beta is a Bible prefix, and alpha beta gamma is a Bible prefix, right? These are the Bible prefixes. Now, given the Bible prefix, can you tell me the bottom of the stack? If this Bible prefix is given, can you guarantee me what is the bottom of the stack? We can always tell the bottom of the stack, right? What is the bottom of the stack? Bottom of the stack. What is that? Because if this is a Bible prefix, which is the prefix of the stack content, it must be starting with alpha, right? Stack is alpha. And alpha beta also, right? Alpha beta. Or you can say alpha beta gamma also. So given this, can you tell me what is the bottom of the stack? Basically, if this is a Bible prefix, then it must be like this, right? It must be like this. Okay. Maybe on top of that, there might be something else, right? So if some Bible prefix is given, that it means that stack is starting with this. Then tell me, can the stack start with plus? Do you have anything to go for plus? Any state if you use plus here? stack will not go to any state. This automata will not go to any state if you use plus, right? So that's why this is not the Bible prefix. This is not the Bible prefix, not Bible prefix. Right? This is the Bible prefix, and you need to append ID. Let's just check. No, suffix is ID, right? Understood? So what is the Bible prefix in nutshell? What is the Bible prefix? What is the Bible prefix? You need to basically whatever is in the stack, you can say prefix of the stack content, right? Prefix of stack content is Bible prefix. Okay, which means that let's suppose this is the stack content and this is yet to read, right? If this is valid rational form, then you can always append, okay, you can always append something to the Bible prefix, and then you can say that this is the whole thing is a right sentence form, right? Right sentence form. You can always append something to the Bible prefix, and then you can say the whole thing is a right sentential form. For example, let's suppose, okay, can I say alpha is a Bible prefix? Can I say? Yes, right? Now tell me what we need to append in alpha such that it is a right sentence form. What we need to append in alpha? Need to append to get right sentence form. Can you tell me? We need to append beta, gamma, ABC, isn't it? This is what we need to append. This could be terminals, non-terminals, but doesn't matter. Can this be non-terminals? Can this be non-terminals? No, right? This is yet to read. How could be the non-terminals? It is not non-terminals, but this is the only non-terminals. I mean, if at all there are, right? So what we need to append this much. Okay. Now you tell me. Can alpha beta be the Bible prefix? Can alpha beta be the Bible prefix? Tell me. Yes, right? Alpha beta is definitely Bible prefix. Whatever is in the stack, the prefix of that, right? The prefix of that. So alpha beta is definitely the Bible prefix. So what you need to append in alpha beta to get the right sentence form? You need to append alpha beta. In the alpha beta, what you need to append? Gamma ABC generated to get the right sentence form. Similarly, if I just ask you, can this alpha beta gamma be the right with the Bible prefix? Tell me, can the alpha beta gamma be the Bible prefix? If yes, then what you need to append? What you need to append here in alpha beta gamma to get the right sentence form? Just ABC, isn't it? Just ABC. So basically this thing we have seen, right? This bar thing. So this whole thing is called Bible. The whole thing is right sentence form, right? Now let me just summarize that what we have seen. See, if I just say something like this, then this whole thing is right sentence form. And what are the possible Bible prefixes? I mean, Bible prefixes, can you tell me? Alpha, alpha, beta, gamma. Can the beta be the Bible prefix? No, right? At least looking at this, no. Okay. Can gamma be the Bible prefix? No, right? Okay. Cool. Now, what is the right sentence form? Okay, you have not seen that lecture, right sentence form. In the RMD, what we have, okay, that is called right sentence form. So let's suppose we are having the RMD. Then let's suppose this is going to small v, and then small v, let's suppose capital C. This is going to, let's suppose, small c, and then ABC. So all are the right sentence form. This is a 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 right sentence form. So whenever you have the RMD, whenever you have the RMD, these things are called right sentential form. Okay, these things are called right sentential form, right? So bottom-up parser is nothing but doing the right sentential form only. So we always have the valid right sentential form. So which means you start with the this one, then you go here, you go here, you go here, you go here, right? So all of this is the right sentential form. Okay. So let's suppose you start with this. You push that in the stack, and then you let's suppose you are saying that you push that in the stack, and then you are reducing this small into capital A. Let's suppose, okay, you are pushing that in the stack, so which means you are having this, and then from here you are going something like this. Tell me, is this a rational form? Yes. Is this ABC is a rational form? Yes. And then let's suppose we are pushing this B also and then C also. Okay, this B also and C also. And then is this ABC a rational form? Yes. And then you are converting this BC to capital B. Is this AB a rational form? Yes. Right. So everything is a rational form that we have in the bottom of parsing. Okay. This bar thing, the complete thing is rational form. Or what is the rational form? This is basically rightmost derivation. Okay. Rightmost derivation. Whatever the string we have in the rightmost derivation is called right sentence form. Okay. So alpha, beta, gamma, these are the Bible prefixes. And then this is the right sentence form. And then what are the possible handles here? Can anyone tell me what are the possible handles? In this particular diagram, can you tell me what are the possible handles? Possible handles. Can the beta be the handle? Can alpha be the handle? Can can alpha beta be the handle? Can gamma be the handle? Can beta gamma be the handle? Tell me. Let's suppose this is A, this is B, this is C, this is D, this is E. Can you tell me? Can the beta be the handle? No. It is not on the top of the stack, right? Can the alpha? No. Alpha beta? No. Can the gamma? Yes. Can the beta gamma? Yes, right? Okay. So whatever is the top of the stack, right? Top of the stack. So given this, the whole thing is rational form. This could be the handle, this could be the handle, and like that, right? And then whatever is the handle. So basically, can this A be the handle? Can this A be the handle in this rational form? Can this A be the handle? No, right? This A can't be the handle. So basically it must be in the top of the stack. Now can I say the Bible prefix? If this is the handle, right? It must be on the top of the stack. Maybe it is only this much, maybe only this much. Can I say the Bible prefix? It's basically something. If I know the handle, okay, I know the handle, then it is basically it cannot cross the handle. Which means if let's suppose whatever is the handle, maybe gamma, beta, gamma, whatever is the handle, it cannot cross the handle. I cannot say the Bible prefix is this much. I cannot say the Bible prefix is this much. Is this true? That can tell me alpha, beta, gamma, A. Is this the Bible prefix? Alpha, beta, gamma, A. Is this the Bible prefix? No, right? No Bible prefix. It is not the Bible prefix. Whatever is the content of the stack, prefix of that is a Bible prefix. So if I tell you this is the content of the stack, okay, then can you tell me the Bible prefixes? Yes, alpha, beta, okay, alpha, beta, gamma. These are the Bible prefixes, right? Okay. Now, in other words, instead of saying something like this, in other words, if I just say, okay, instead of telling you what is the stack content and all, if I just say, if I just say that gamma is a handle here, okay, gamma is a handle. Can you tell me now Bible prefixes? If gamma is a handle, now can you tell me the Bible prefixes? The answer is same: alpha, beta, gamma. So whatever is a handle, it cannot cross. It cannot cross that. See, either I say you this or say you this. Aren't both the fine? See, instead of giving you the vertical bar, okay, I'm telling you the handle. Okay, instead of giving you the vertical bar, I'm telling you the handle, which means either I say like this or I say like this. Isn't both are the things are same? If I also tell you the handle, now from this can't you tell me the Bible prefixes? These are the Bible prefixes, isn't it? Bible prefixes. Okay, is this fine? So if I just ask you a true false question, Bible prefix cannot cross the handle. Bible prefix is a prefix of any right sentence form, any right sentential form where we do not go, we not go past by handle. Past by handle means we do not cross the handle. Is this true or false? Given any right sentence form, see, I give you any right sentence form. Let's suppose I give you this right sentence form. Okay, I give you this right sentence form. Let's suppose ABC. So can you tell me? Can you tell me what are the Bible prefix here? See here, if ABC is the right sentence form, then what could be the content of the stack? Content of the stack is this much only, right? Then if BC is the handle, then you can have A. So what is the Bible prefix here? If this is the handle, or maybe let me just tell you here in this ABC, what is the Bible prefix? Okay, if I just give you ABC, small ABC, what is the Bible prefix? What is the handle? Handle is small a, right? Handle is small a here. So stack will be having this only, and then you will be converting that to capital A. So what is the Bible prefix? Only small a, because this is the handle. So you cannot cross this small a. Tell me. Can if I have something like this, okay? If I have S gives AB, this rightmost derivation, this is A gives small b, capital C, then this gives this gives ABC. Okay. Tell me if you want to parse ABC, how you would have gone about parsing? Want to say something like this? Want to say something like this? And then what you will say after this? Okay, and after this, what you will say? You will reduce that to small a to capital A, isn't it? Isn't it? And then you will say something like this. Then you will say, okay, this will go to something like this. Then you will say this will go to something like this. Then you will say this will go to something like this. Then you will say this will go to S, right? Isn't it? So these are the set of steps in bottom up parsing, right? These are the set of steps in bottom up parsing. Now tell me, if given this ABC, in this, tell me the Bible prefix. Only in this, okay? Only in this, tell me the Bible prefix. Now first to recognize the handle. What is the handle here? In this ABC, what is the handle? Small a, right? Small a is the handle. So whatever is before, including this small a, is basically the Bible prefix. So what are the Bible prefixes? Small a only, right? Small a. Can this small be the Bible prefix? Can this be the Bible prefix? No. So basically, whatever is the handle, okay, you just put a bar. You just put a bar there, and then you can take the prefixes, right? Then you can take the prefixes. Can you say this AB is the Bible prefix? Can A be the Bible prefix? No. Can AB ever appear on the stack? Just tell me. Just tell me. Will AB ever appear? A will appear. Capital A will occur. Can small be ever occurring? Small be ever occurring on the stack? Just tell me. No, right? So if someone asks you what is the Bible prefix in a given string, then how to tell? You just need to tell. See, let's suppose I say if W3 is handle, then which of the following are Bible prefixes? Right? So what does this mean? If W3 is a handle, it means you need to put a bar here, right? Isn't it? Someone is telling you the handle, you need to put a bar there, right? That's all. Okay. After W3, can you put a bar here? And can you still say W3 is a handle? Can the handle be in the between of the stack? No, right? Can you put a bar here and can you still say W3 is a handle? Can handle be the out of the stack, not in the stack? No, right? So if W3 is a handle, you must put a bar here. Okay. And now, once you put a bar, you can definitely tell me the Bible prefixes, which means if someone is putting the bar, then can't you tell me the Bible prefixes? Tell me. W1 is a valid Bible prefix. W1, W2 is a valid Bible prefix. W1, W2, W3 is a valid Bible prefix. Right? Can the W2, W3 is a Bible prefix? Tell me. Can this be the Bible prefix? No, right? So if someone is telling you the handle, then you can definitely tell the Bible prefix, right? I mean, for at least for this given string. Now in the Bible prefix, there could be two type of things. If someone asks you the set of all Bible prefix, then how to solve this question? Then draw LR0 automaton, right? And treat every state as final state. Initial state is known, right? Initial state is fixed and known, right? Okay. And if someone asks you given a string, okay, given a string, tell me the Bible prefix. Then locate the handle. Yeah. Then in that case, locate the handle. Put a bar and tell, right? And tell prefixes. Is this okay to everyone? So basically, this Bible prefix concept is not very known to many aspirants. That's why I've taken a little bit of time there. Okay. So what is a Bible prefix? So basically, whatever can appear on the stack, right, is a Bible prefix. So if alpha, beta, gamma is appearing on the stack, then you know the Bible prefix. Now tell me if this is the stack content. Can you tell me? That maybe 10 minutes back, okay, if I go back in the time, can I say that alpha was the only stack content 10 minutes back? Isn't it? Alpha was the only stack content. And then I might have added beta, and then I might have added alpha, beta, gamma, right? So that's how it is building. So basically, if someone is telling you this is the stack content, it means that alpha is also a Bible prefix, alpha, beta, gamma. And what is the Bible prefix? That can be on the stack. Stack content is a Bible prefix. That's all. And very important property of the Bible prefix is this. If this is the Bible prefix, okay, if this is the Bible prefix, then it means you can always add some terminals to get the right seller form. Okay, add some terminals to get a right sentence form. Okay, which means if someone says that alpha is a Bible prefix, then can you not add some terminals? You just go 10 minutes back and then you say, okay, this was alpha and then some terminals, right? So this whole thing is a right sentence form. So if there is some Bible prefix, you can always add some terminal. Can you add some non-terminal and terminal mix of them? Can you add some mix of them? Yes, right? Maybe you will add beta, gamma. It might be mix of them, right? It might be mix of them. So maybe you can add mix of them, but you can always add terminal at least. For the terminal, we are sure that we can always add the terminals, right? We can always add mix, but terminals is for sure. Let's just solve this question. Which of the following is true about the any valid state in shifted parsing? A Bible prefix appear only at the bottom of the stack and not inside. What do you think? Bible prefix appear only at the top of the stack and not inside. The stack contain only the set of Bible prefix. A stack never contain the Bible prefix. So what is the answer? The stack contain only the set of Bible prefix, right? Bible prefix only appear at the bottom? No, no. This is also, I mean, the whole thing is also the Bible prefix. I mean, this is not very clearly well framed, to be honest. But yeah, the whole thing is the stack content. Whole thing is the Bible prefix. So if I have to choose the best option, then I will be choosing this C. The stack contain only the set of Bible prefix, right? Understood? Okay. Now tell me, this true false shift is allowed if after shifting the content of the stack is still a Bible prefix. What do you think? This is true or false? This is also true, right? This is also true. Okay. So this was about the Bible prefix. Now I hope you understood what is a Bible prefix clearly. So can anyone tell me what is a Bible prefix? Whatever can appear on the stack is Bible prefix, right? How to recognize? Using the automaton. Using the automaton. Okay. So this automaton is telling me that what can be on the stack, right? What can be in the stack? This is, if let's suppose this is A, this is B. So this AB can be in the stack and I will be here. Let's suppose there is no move of C. Okay, there is no move of C here. Then can the ABC on the stack? Can you ever have ABC on the stack? If there is no shift move on C, no, right? If there is no shift move on C, we will not be having ABC on the stack. So basically, this automaton is telling me that what could be on the stack, and that is nothing but the Bible prefix. Okay. Okay. See, in LR1 parsing, currently we have seen LR0 and SLR1. Okay. In LR1 parsing, we will be having something like look ahead. I will tell you later on. But yeah, we will be having something like this comma and then plus. Okay, something like comma out or something. So this is called look ahead. Okay. Now I'm telling you one thing here. So regarding the Bible prefix, now suppose I give you some grammar. Okay. Suppose I give you some grammar, and I ask you that what are the possible things that can occur. Okay, or that can come. Let's suppose T plus F or something. Okay. What are the possible things that can come? So until and unless I change this grammar, let's suppose I write the comma something. Will this change my thing that okay, what can appear on the stack? See, what I'm trying to say is that in LR1 parsing, we will be writing something like comma or something. Okay. So there, don't get confused that Bible prefix will change. Bible prefix are still same. Bible prefix is telling you what can appear on the stack. Here, this comma that we will see later on is basically just a helpful thing, just a helpful thing to tell me whether I should be reducing or not. Okay. But what can appear on the stack or what can come, that is anyway can be told by the LR0 automaton. So we will understand this SLR or the LR1 parsing later on, but I'm telling you that comma don't change the Bible prefix. Okay, we will see that later on. Okay, don't worry. So now, given this, let me ask you one question. Let me ask you one question. Suppose, suppose you are in some state. Okay, let's suppose that you are solving this particular question. Okay, and then let's suppose you are saying that you are in the state. Maybe let me just go. Just go back a little bit. Okay. So suppose you are solving this, and here you are in state 6, and here you are in state 7, right? Now, how you got to know you are in state 6? Because AAB, small a, and then capital this small b is in state 6, and then small a, capital B is state 7, right? That's how you got to know. What you did, what we call this? We call this rerun of DFA, right? We call this rerun of DFA. Rerun DFA. Is this okay to everyone? Coming, let's not worry about the Bible prefix. Now let's just come back to this original question, that original concept of rerun of DFA. So how we are getting to know the states, right? I hope that is fine, right? Now you tell me, do you really need to rerun the DFA? See, aren't we doing the same thing again and again? That A, on this A, we are at the state 4, and now at B we are at the state 6. But if this B is getting reduced to capital B, should you again rerun or you already know? See, till now you are in state 4. Okay. Suppose I tell you, till now you are in state 4. Suppose I tell you here only. Should you need to rerun or you can just pick from state 4? That from the state 4, capital B the 7, right? Tell me. You understood my question? What I'm trying to say? Let me know. See, what I'm saying here, that what I'm saying, let me go to the slide. See, here we got to know the state numbers, right? We got to know the state numbers. How? We were rerunning the DFA. A, and B. Okay, state 6. A, and capital B, state 7. But my question is that, do you really need to rerun the DFA? Do you really need to rerun the DFA? This is my question. If I just tell you here, that state is 4, can't you just pick from state 4? That okay, now till now state was 4. Now if small b is there, then state 6, small capital B is there, state 7. If I just tell you state 4, till now? Do you really need to rerun the DFA? That is my question. Similarly, if I tell you here also, till this point, what is the state? This is also state 4, okay? Till this point also, if I tell you state 4, after this is small a, do you really need to rerun or I can say from this 4, if capital V is coming, then you are in the state 7. Isn't it? So are you guessing what I'm trying to say? We want to optimize this rerun. So how to optimize this rerun? This is my question that I'm saying, right? How to optimize this rerun? Which means that instead of rerunning it again and again, what we can do, instead of rerunning this again and again, we can save the state for every of this symbol. We can save the state, right? Isn't it? If I'm saving the state, which means instead of just saying that, okay, instead of just saying this small a, after this small a, what is the state? The state is 4. So here, if I just write 4, okay, which means a in the stack I'm pushing a and 4 also. A. So see, earlier what we were pushing in the stack, only a, but now I'm pushing a and 4, okay, and then if again small a is coming. See, let me just tell you that what I want to do. See, instead of just pushing the small symbols, okay, I also want to push the state number so that I don't need to I don't need to do that much tension. I can directly do, okay, without basically rerunning. Let's suppose initially the stack content, okay, stack my invariant means that what is always true. So I'm saying that stack is always containing the state number on the top, okay. Let's suppose stack contain state number on top, okay. So initially it is containing 0. Now suppose I want to pass this string which is a b AB. I want to pass this, okay. Initially stack is containing 0. Now a I will push and then it will be AB. Okay. You tell me on 0 where this a is going. On 0 where this, I mean after this a I will go to 4. So I will say 0A4 AB. Okay. Earlier I was not writing the state number. That is the only difference. So how it is optimizing? Let me just tell you. Now if this age coming next, now what will happen? 0A4 A, and then this is BAB. Now can you tell me on this A where are you going? See, earlier we were rerunning the DFA, but now you can just pick from 4. Okay, from this 4, if A is coming, you are going to 4 only. So 0A4 and then 4. So what I'm doing, let me just tell you. In these two state numbers, between these two state numbers, there is a symbol, right? Small a. So on this small a, this 0 is going to 4. Okay. On this small a, again, this 4 is going to 4 only. Okay. Now if I have if I have B, so till now you will understand like this. Don't worry. See, if I have B, now can you tell me if you are in state number 4 and if you have B, then where are you going? If you have a small b, where are you going? In 4, if you have a small b, you are going to 6. Just write the 6 directly, right? So are you getting the difference between previous and this one? Okay, you will get to know. See, I am also maintaining the state number. Now you are in the state 6. What you need to do? You need to reduce this small b, right? You need to reduce this small b to capital B. So if you need to reduce this small b, you will be basically popping out till a small b. Okay. So which means state number will anyway get pop out. So basically you will be having 0A4 capital B. Okay. See, earlier AAB, on earlier this AAB I reran, right? Do you really need to rerun or you can directly pick from this 4? Then okay, till now it was 4. If I'm 4 at capital B, I will go to 7, right? And this is small AB. Let me know. Have I not optimized this? Are you understanding my my feelings? What I'm trying to say. See, what we are doing. We are earlier. What we did. We were just pushing the symbols. Okay, we were not pushing the states. But what I'm saying, let's just push also the state. For every symbol, let's just put one state. For every symbol, okay. For this A, I'm pushing 4, and then if this A is coming, this is going to 4. Then if B is coming, okay. Then here I'm going to 7. Now, if you're in state 7, for this AB, Okay, you will reduce to capital B. AB means you will reduce, you will pop up till this A. So you will say that this will be 0 A4 is as it is. This thing will get to B. Now, should you rerun, or can you directly tell me on this 4, if you are in 4, if capital B is coming, then go to 7, isn't it? See, am I not saving my rerun here? Am I not saving my rerun? See, earlier we need to rerun, right? But here we do not need to rerun. So now let's just keep on doing it. So from here you are in the state 7. This will say that this AB will get to capital B. So basically AB means if these are the two symbols, then how many symbols you need to pop out? If these are the two symbols, you need to pop out actually double of that, because there is a state number also. So 4 symbols you need to pop out. So 1, 2, 3, 4. Okay, you need to pop out this AB. So this is 0 as it is. This AB will get to B. Now can you tell me on this 0, if capital B is there, then 3 will be there, right? AB. Then what will happen? The 0 is as it is, B, 3, and A will come. So on 3, if A is coming, on this 3, if A is coming, you are going to 4, B, and then 0, B, 3, A, 4, B. On this 4, if B is coming, then you are going to 6. Okay, so this is 6. 6 is a reduce. 6 is a reduce. So this B will get reduced, right? Okay, so this B will get reduced. Let's just reduce this. Now, can you tell me this B will get reduced to what? Capital B. So this is 0, capital B, 3, A, 4, capital B. Can you tell me, should you rerun, or can you directly tell me from this 4, what is this capital B? 7. Right? You don't need to rerun, basically. Okay. For every symbol, if B is coming from 4, you are going to 7. It's like that. Okay. If B is coming, then dollar. Okay. And then if you are in 7, then AB. If you want to reduce this AB, then how many symbols you need to pop out? You need to pop out, if these are the 2, you need to pop out double of that. You need to pop out 4. So you need to pop out this. So this will become 0, B3, and then this is capital B. Now this whole thing is capital B, right? Now where are you going on capital B? If on 3 you are going to the 5, right? You're going to 5 $1. Now on 5 you are saying BB. Okay, this BB you need to reduce to capital S. So you will say that you need to pop out 4 symbols, basically 1, 2, 3, 4. 0 S dollar, right? Okay. If you're in 0, and then you got the S, then you will go to $1. And then if you're in 1, and then you got the dollar, which means you accepted it, right? This is accept, isn't it? So basically what we are doing here and what we did earlier are same. It is just that here I want to optimize this. I don't want to rerun. Is this fine? So for every small symbol or the capital symbol, we are saving the state. Okay. For every symbol, we are saving the state. Okay. We are writing the states. Isn't it the amazing thing? So that is called bottom-up parsing algorithm. Okay. That is called bottom-up parsing algorithm. Okay. See, all the GATE aspirants just by heart that algorithm. They do not even understand what is this rerun of the DFA. Okay. So now you understood the basic brute force approach. That what is the brute force? Rerun of the DFA is the brute force. But we can optimize this using this algorithm. This algorithm says, very simple algorithm. It says that stack will contain the state number and corresponding symbol. Okay. So at start, stack will have only 0. Okay, 0. This is the stack that will be having. Okay, state number. Okay, and then you will be whenever there is some input 0. Let's suppose some input small a is coming. Then what you will do? On 0, small a is coming. Let's suppose it is going to 1. Then you will write like this, right? You always write on the top of the stack. You always write the state number. If you want, you can maintain this state number in the separate stack. Which means you can say that, okay, A, B, C, I will be maintaining here. 0, 1, 2, I will maintain the separate stack. Can you do that? Yes, you can maintain for these numbers. You can maintain the separate stack. It is up to the implementation. I have just maintained only 1 stack. Okay, you can definitely maintain the 2 stacks where you are putting only 0 and 1s. I mean these numbers in 1 stack. As usual, you are just putting your symbols. But at least what I'm saying, we just need to remember the states. Okay, so the bottom-up parsing is optimized version of rerun of DFA. Okay, this algorithm is basically optimized version of version of rerun of DFA. Okay. I hope that is fine to everyone. Understood? So basically in this lecture, it was little heavy lecture, I know. In this lecture, we have discussed many things, right? We have discussed that what is rerun of DFA, which is most important. Okay. Which was the most important? Given any state, any state of LR0 automaton, can you tell me the possible stack content? We can tell possible stack content, right? And also what we discussed, Bible prefix. Also what we discussed the bottom up parsing optimized version, right? Bottom up parsing algorithm, which is the optimized version of rerun of DFA. Optimized. Basically, this rerun of DFA is just not. I mean, this is not in most of the places. Actually, in just one of the word rerun DFA, something like that. Some one word I just saw, and from there I just connected all of this picture. Okay, just one word I have found. I have not even found this concept at any place. Only in one slide, at just one word rerun DFA I have found, and from there I have connected all these dots. That I got to know that okay, this bottom up parsing is just an optimized version of rerun of DFA. Otherwise, in most of the places, in all the places, not just most of the places, you will directly see this bottom up parsing that they will say that okay, just the state number you can save and all, and you will never get the feeling of this DFA, what this DFA is doing. Okay, see, many of the aspirants, right? Many of the aspirants, they do not even know that what is this capital V means. So they will, which means that they will say, if we ask them that okay, what does this mean to say the capital B is coming? Because capital cannot come in the input, right? Input is containing small a, small b, small c, something like that. What does it mean to say in the DFA capital B is coming? They can't even answer this. Now, can you tell me what does this capital B means? It means that something will come that will reduce to capital B, right? Capital B cannot come directly in the input. Obviously, no. Capital B cannot come directly in the input. But something will come that will reduce to capital B, and then we will rerun the DFA, right? We will rerun the DFA, and then we will get to know that what is in the state, current state, right? Okay. So that is all about this lecture. I hope you understood the feeling of this bottom-up parser, especially that how this DFA is working. Okay, the rerun of DFA is extremely good concept, extremely important concept. That's why in the starting itself, I said this is most amazing and most needed also, so that you can get the crystal clear idea of bottom up parsing. That what this bottom up parsing is happening. At least what is this DFA? You should understand that how this DFA is working, right? Okay. So I hope you understood that how this DFA is working. Now that is all for this lecture. Thank you everyone. Take care. Bye bye.